लाइक 8 से छोटा हाइटेड है। हाँ हाइटेड है। 8 में है? नहीं हाइटेड है। पूरा 8 से छोटा। एज तो छोटा है। मे से छोटा है। मे भी क्या होता है? ये तो पता है यार। कौन चला है कौन? है हमारे क्लास का बंदा है। गोरा वाला एकदम। तेरी क्लास का। तो वो 8 से छोटा क्यों होगा? है वो छोटा है तो नहीं मालूम। हमें लगता है आज तक 8 से बड़ा है हम लोग से। बड़े तो कहो नहीं बॉल। हाँ वो शायद 10 बॉल। पेडो पेडो। पेडो है। मुझे मारने। नहीं सारा होंगे बड़े बड़े
होगा वे मुंबई नहीं होगा निकल
किसकी बोलते हो ओम फार्मा अच्छा उसकी वजह ठीक ये पहन के जा रहा हूँ क्लास में ये घूमने का क्लास मुझे सिर्फ यही मोटिवेशन दे रहा है मैं यही सोच रहा चलो एमबीबीएस में टाइम है एमबीबीएस यही सोच के मोटिवेशन रहेगी पर लास्ट होगा इसके तो बननी चाहिए क्या बचा अब तो हो गया सो गया अरे ये सब लेक्चर बंद हो जाएंगे ना एमबीबीएस ऐसी टेस्ट तो होगा एसबीएस भी अगले हफ्ते में खत्म कर देंगे फ्राइडे को रिजल्ट चेक होता है पूरा एसबीएस खत्म कर देंगे साउंड लेवल 1 लेवल 1 कर लेंगे लेवल 2 कर लेंगे वर्क एंड एनर्जी लेवल 1 कर लेंगे वर्क एंड एनर्जी का खत्म एसबीएस पूरा ये आता है
ऑल टाइम से आ रहा है
मैं होमवर्क ले लूंगी गूगल से छापना देगा क्या इतना अबे यार क्यों नहीं देगा हम लोग खुद से करना है भाई मेरा शायद लॉस ऑफ मोशन बाकी है मैं बोलूंगी उनको पता नहीं चलेगा तो मेरा हम क्यों याद रखते हैं मैं तो बोल रहा हूँ वर्कशीट में सॉल्व करेंगे so smart बड़ा स्किल है वेरी स्किल को फंसना पड़ेगा नहीं बट थोड़ा और उसको ग्लो कर ऐसे करें बहुत लोग हो जाना पूरी क्लास अच्छी लगती है हमारी क्लास में सबसे अच्छा दिखने वाला लड़का शायद परी नहीं तो तू सोच के कितने गंदे स्टैंडर्ड्स हैं देखा ही नहीं उसको परी को है परी पकड़ दिखा क्या कर रहे हो मेरे बच्चे नारियल पूरे दिन नारियल लेके आओ इसको फोड़ने का ही आज दिखाई दी है का वो भेटून कोण जाणार मला आवडत नाही तुला मला भेटायला नाही ग तसं नाहीये मग येते काय जाते काय किती दिवस मी आले मग कसं झालं तुझं कथ्थक एक्झाम कसं झालं कथ्थक काय माझी भरतनाट्यम आता अजून कधी करून दाखवणार मला तू का आम्हाला काय दाखवायचं मग मला दाखवा भेटून आता 19 ला आहे चालेल मग ते आता झालं सगळं क्या बोलते कैसे एग्जाम हाँ स्कूल एग्जाम कैसे गेला कितनी मैंने वहां से
हाँ मैं आता था बट
92 ओवरऑल लगी है।
हाँ
विष्णु जी स्कूल का एग्जाम हुआ एक नहीं बताया तुम्हें कितना मिला ओवरऑल? परसेंटेज में आते क्या अंदर क्या हुआ? अकेला बैठा है ये लाइट सगळ्या ऑन करें केला विष्णु अनुराग ना हे वगैरह चला गया। हाँ नहीं मैंने कॉल किया तो बताया नहीं। हाँ बस
क्या फ्लेवर है
ग्रीन ए एसपीडी मैडम आएगा। अच्छा बाकी सब पिकनिक है।
हाँ
फिजिक्स का डाउट है और भी है तुम्हारा डाउट किसी को डाउट नहीं मनस्वी तुझे विश्वजा तुझा कुछ भी नहीं है डाउट अनुराग सब डाउट क्लियर तुझे एग्री नहीं है संजीती मनस्वी अनुराग टेस्ट दे दो नेक्स्ट मंथ में मैं शेड्यूल बनाऊंगी।
फिजिक्स का
नहीं फिजिक्स की मैं क्या बात कर रही हूँ आपको डाउट है तो एक्स्ट्रा लेक्चर मांग सकते हो ऐसा मेरा कहना है ठीक है।
थैंक्स संजीवी
यार हाँ देखा देखा देखा
आ गया ये
ये है
पर पूछना मुझे जो फॉल्ट सब में
एग्जैक्टली कोई अगर शक्ल अच्छी है तो छोटा सा है कोई लंबा है तो शक्ल अच्छी नहीं है।
अरे वो लंबा सा वो सीबीएसई का था क्या 10 सीबीएसई का जिससे से सोचना फॉल्ट कर रही
नहीं
वैसे अरे हाँ Ireland to attend MBBS. Yes. And
सही है तू नहीं करता चल
मेरे पास ऑप्शन है मैं कितनी बार तुझे समझाऊं ये चीज
ये अपन ऑप्शन ना लो
हाँ
मैंने एक और ड्रामा किया करते हैं।
हाँ क्या क्या कहेंगे
अबे इतना कुछ नहीं एक तो मेरी माँ ऑफिस में तो लाइक मैंने ऐसे फोन पे थोड़ा बहुत रो दिया झूठा मूठा
सो बैड गिल्ट ट्रिप करवा के बेचारी मम्मी को हे कौन तेरे लिए संजीती कोई भाई बहन है नहीं एक माँ उसको भी तो इमोशनल ब्लैकमेल करते
So ये trauma to your mother. So ये trauma to your mother.
ओके अंडरस्टैंडेबल
तेरे से भी छोटी है नहीं थोड़ी बड़ी
थोड़ी बड़ी मेरे से कितनी
तुझसे भी बड़ी है।
अच्छा वो भी ठीक है मेरा नॉर्मल वेट है
मेरा बाप बहुत लंबा था फेस के लिए
मैं इतने बाप के जोक्स मार सकती हूँ but then I don't want to get
मार दे बात हो गई
दूध लेने गया था
मेरा बाप देखा भी भूल जाएगा वेरी डरावना एंड वेरी मॉडर्न
मुझे कितनी कैसा लगता था
कोरावड़ा था आंखें बहुत बड़ी थी
क्या गंजा
पोटा था।
अरे अरे भगवान छी 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 इससे ड्रामा
स्टॉप किया
मुझे
अभी उसने अकाउंट डिलीट कर दिया।
So you lost one, right? Count one count. Okay, so not bad. I thought you will also tail him. Huh? Okay. So any questions here? Proceed. The count of boys is reducing drastically. Some threat pass. Huh?
So I was the only boy at first, and then
You were the only boy?
At first.
so I used to be the only boy.
At first. No, I used to accompany you all the time.
Yeah.
So I was there, right? Just imagine if there was a lady teacher. Huh? Okay. And in most of the schools, all the teachers are mostly lady teachers, right?
Yes, yes.
Most of them.
So there are types of instruments also, right?
There are types of
There are stringed instruments, percussion instruments,
flute.
but sir, one more type was there.
I'm not familiar so much.
Sir, that was in our last year syllabus.
Okay. Percussion, string, what else? That's it, I think.
There were 3 types.
3 types we said already, right? String,
Yes.
pipe, and percussion. So 3 types.
Exactly, I didn't understand the quality of it.
Quality mein the frequency and amplitude both are same. Like if you play a flute, putting in same energy, okay, and play a guitar, they both are, let us say, of same level in terms of height, amplitude, and same frequency. Still, they both will sound different because they generate different types of waves. Disturbance is different. That's why. Are you satisfied? थोड़ा पढ़ना पड़ेगा. This is a heavy chapter.
This is the last chapter.
This is last
There
chapter.
in our last year syllabus.
It was there in last year's syllabus also.
Yes.
So I left you with certain questions, right? How many of it you could do? So basically, what is the formula we have learned so far? So far, the formulas are F is equal to 1 by T and V is equal to F lambda. So far, only these 2 formulas, right? So we have a question like a sound wave has a frequency of 2 kilohertz and a wavelength of 35 centimeter. How long will it take to travel 1.5 kilometer?
Sir, can you off the AC?
Is the remote here? Okay. Off it. Okay, so sound wave has a frequency of 2 kilohertz. 2 kilohertz. The unit of frequency is hertz or per second. 1 by T per second. Then what is given? Wavelength is equal to 35 centimeter. How long will it take to travel 1.5 kilometer? You have to find the time. Time taken by wave to travel 1.5 kilometer. This you have to find out. So how do we do this? Everybody try.
Sir, we need to find time taken by one wave to travel.
Time taken by the wave to travel 1.5 kilometer. Wave is the disturbance. So how can you find it?
So isn't time taken by a wave, wouldn't that be time period? So wouldn't time taken by wave be time period?
Time taken by wave is time period.
That's the same as time period, right?
Time period में only the time for wave to travel just one wavelength.
What is the whole wave itself?
Not whole wave, yeah. It's like, let's say you have like this. So this is one wavelength. But you have to find the time for 1.5 kilometer. So number of wavelengths in 1.5 kilometer into time for one.
We don't know.
We don't know the velocity.
So I'll give you the formula for velocity. If you know F lambda, the product is velocity.
Okay, sir.
Yes.
Yes, sir.
Everything is on the board.
So what is the unit of wave?
Wave or wavelength?
Okay, sir.
Unit.
This is also
Unit of
Sir.
So like what is the symbol of wave? V. Velocity.
V.
Sir, sorry.
Symbol of velocity is V.
No sir, the unit.
Meter per second.
In this question.
Are yaar, velocity is velocity anywhere. Meter per second. Distance traveled in unit time.
Because it wasn't given in the question like.
Everything is given in the question.
No, they didn't say how to like in meter per second or anything like that.
No, velocity is always visible. Always, irrespective of any branch.
Sir, what
Everything
is the
velocity.
2K?
Kilohertz.
Sir, then what will be the unit for velocity?
Yeah? I just told you meter per second.
Sir, but there is centimeter in lambda, right?
So convert that in meter.
Yeah.
You see, now you're thinking. If I do it, it will happen in 1 minute.
Sir, 1 second.
Waiting. No. Is the question understood?
Yes.
Yes, sir.
Continue. So this question can be easily done actually the way I have given it on the board. So should I give you a hint?
No, sir, I'm doing
Sir,
Okay, last 2 minutes to try, and then I'll do it on the board.
Sir, is it 0.2 seconds?
0.2
seconds, but I'm getting.
So I'm getting 2142.85 seconds.
You're getting?
I'm getting 2142.85 seconds.
Sir, what is the answer?
2.
2142.85.
The answer is 2.1 seconds. What's going on?
They're cutting.
I don't know. I resign. I give up.
I resign. Sir, one second.
Yes, what's the news?
Sir, just a second.
Why no clue? I mean, I have given the diagram also. After diagram, if you can't do it. Okay, the clue. This much distance is 1.5 kilometer. Okay? And you know this distance. So if you know how many number of
1
wavelengths.
by 2. Sir, 1 by 0.2.
I'm talking about this logic. If you know the total distance
So I
divided
tried
by,
to solve it like that, but
you will get the number of wavelengths in this.
so that's what I did. So I don't know.
So if you get the number of wavelengths, then time taken by one wavelength you just multiply. What is time taken by one wavelength? Reciprocal of this.
Sir, what is the velocity is 0.78 meter per second.
So other thing is, imagine this is d. D distance is this. Okay, you have to find since velocity of the wave is equal to distance traveled by wave or upon time, right? Distance traveled is d. Okay, but what is v? F lambda equal to d by t. So what is t? Therefore t is equal to d upon f lambda. Okay. What? T is equal to d by f lambda. It's as simple as this. V is, since V is equal to f lambda for wave. This is the general formula for velocity. Displacement upon time. Now she's understanding so fast.
Sir, what I did?
So this is what you did. Laughing at yourself. Okay. So what is
So they should give us all the formulas before giving us the version.
no, then what will you do? This into 10 raised to 3 meter. Convert V into meter. So it is 1.5 into 10 raised to 3. What is frequency? 2 kilohertz. So this is equal to 2000 hertz, right? So 2000 hertz. Or kilo ko 2 raised to 3 hertz. What is lambda? Lambda is 35 centimeter. This is equal to 35 meter. So you put 0.35. That's it. You have to do only this. So what is it? You see, I told you divide d by lambda.
So why do you write 2000 hertz as 2 into 10 to the power?
Okay, you divide d by lambda. So you'll get number of wavelengths in this distance. Okay, into you have to do t. Right? How much t? Time for one wavelength is 1 by f. So this will be 1 by f. This is the time for one wavelength. Because f is equal to 1 by t. So therefore t is equal to 1 by f.
So
So this is the अरे listen रे बाबा तू सुनता नहीं है जरा सुन चुपचाप. Total distance divided by wavelength is what is it? Number of wavelengths in this distance. you know total number of wavelengths is this distance into time for one wavelength. That will give you the time. If I have n wavelengths in 1.5 kilometer into time for one wavelength, both answer. So this formula is also giving me this formula. D by f lambda.
So can I do that step again? Like
Which step?
the 1.5 into 10 to the 1. Can I do that step again?
I have done this now. What is to be done again?
So could you show it again? I didn't understand.
This you understand.
Yes.
V is equal to d by t. Displacement upon time. But what is V? Speed of wave. It is expressed as f lambda. And what is given to you is f lambda.
So I understood the formula, but like
Now, when I take t here, f lambda will come here, cross multiply. So we get this. Now substitute. D is given in kilometers. So 1.5 kilometer is 1.5 to 10 raised to 3 meter.
okay.
This you did not understand. Kilometer to meter. Kilometer is not SI unit. Then, so you asked na, how you got distance is 1.5 kilometer, how you got into 10 raised to 3. That you should ask. Then, what is 2 kilohertz? 2000. So this can be written as 2 into 10 raised to 3. These are, see, physics you cannot do unless you know mathematical simplification. Physics is application of mathematics, it is next level. तो मैथमेटिक्स आनी चाहिए, ठीक है, तो तुम फिजिक्स कर सकते हो. अब मैं तुम्हें यहाँ पे मैथमेटिक्स बताऊं तो फिजिक्स कब सिखाऊंगा? आर यू अंडरस्टैंडिंग? ओके, सो ये देखो ये खत्म हो गया. नाउ अब देखो ये यहाँ पे 2 डेसिमल है तो ऊपर 1.5 into 100 आ जाएगा, डिवाइड बाय 2 into 35. ठीक है, और इसका जो पॉइंट था इसको तुम नीचे ले लो तो इंटू 10 आ जाएगा. तुम ये मेरे से मत पूछो 100 कहां से आया 10 कहां से आया. दैट आई एक्सपेक्ट यू टू नो. ओके, किलो है तो 10 raised to 3 कहां से आया. दैट आई एक्सपेक्ट यू टू नो. ठीक है, सो नाउ ये हो गया. देन 2 5 5 7. So what you get is 15 upon 7. What will be answer? 7 to the 14, 2.1. हो गया. इतना सिंपल है.
Sir, why can't
So what I did was,
Sir, can we do it like we first find the velocity by multiplying f into lambda, and then sir we put the real value
We
of f.
simplify in the end. Substitute the value and simplify in the end. Every step if you simplify, you will just increase the time for solving the question.
Sir, but then I can find the t by just putting the value in the f means frequency.
You can do that also. This is nothing but
Sir,
d by lambda into t. That's what it is. That's what I was telling you. So there are 2 ways in which you can solve the question. Find the t, which is 1 by f, and then d by lambda will give you how many wavelengths in this distance. That also will give you.
Sir,
Sir,
the
if
last
I
step.
don't take the d in my question, then sir, if I don't take the d in my question, then
D you have to take na. How can you do without D?
sir, but where?
What is the question? How much time taken for the wave to travel that distance? How can you leave that?
Yes, sir, but sir, then without that also, sir, because we
Without that, you don't know where you have to. It's like I have stepped out of house. I don't know where I have to go. ऐसा थोड़ी होता है. Then how will you tell time? I am just going. Where are you going? I am just going. ऐसा होता है क्या? You have to know na where are you going. So that's why D you cannot leave. Yeah, that thought came. Na, I'll just go. Came na?
sir, one down. So the last step is that we 15 into 10.
Huh?
So it should be 15 into 10, right? Why did I write 100?
How many decimal places?
So but Nietzsche also you wrote into 10. So
How many decimal places? इधर भी तो है decimal. ये.
oh, okay, sir, never mind.
You have to see everything in totality.
Then why did you write 100 up and 10 down equal to this?
तो मैं तो ये नहीं समझ रहा, अगर मैं डायरेक्ट कर देता तो वो तो सर कैसे आ गया, मेरे को फिर से एक्सप्लेन करो। हर तरह से तुम्हारी चलेगी क्या? आई एम जस्ट नॉट लीविंग एनी स्टेप्स, सो दिस इज फुल स्टेप। आर यू गेटिंग?
Yes.
इसलिए मैंने शॉर्टकट नहीं किया, क्योंकि पहले तुमने बोला सर ये कहां से आ गया, वो मैंने डायरेक्टली कर दिया, इसलिए ऐसा। मतलब आई कुड हैव डन मल्टीप्लाई कर देता तो ये 150 हो जाता या 1500 हो जाता, और ये क्या हो जाता 350 हो जाता, ऐसे भी कर सकते हैं। ठीक है, और ये these are simple mathematics of 5th 6th standard, फ्रैक्शन का है, डेसिमल का है, ये तो आना चाहिए, ये नहीं आएगा तो फिर आगे क्या पढ़ेंगे हम? ठीक है, ओके, नाउ आई विल स्टार्ट विद स्पीड ऑफ साउंड इन डिफरेंट मीडियम। ये क्वेश्चन समझ आ गया ना सबको? तो ये दो ही फॉर्मूले हैं इस चैप्टर में बस। ठीक है, नेक्स्ट इज स्पीड ऑफ साउंड इन डिफरेंट मीडियम्स। दिस इज न्यूमेरिकल 1 सॉल्व एग्जांपल का है तुम्हारे एनसीईआरटी बुक का। ठीक है, स्पीड ऑफ साउंड इन डिफरेंट मीडियम्स। Actually, speed of sound depends on the property of the medium. Medium कितने टाइप के होते हैं? 3 types: solid, liquid, and gas.
So, sound travels fastest in gas, right?
No, solid.
What?
Yes. So speed of sound is maximum in solid. Is maximum in solids. Minimum in gas. And in between in liquids. ठीक है, speed of sound is moderate in liquids, maximum in solids, and in between in liquids. Gas में minimum. Actually, higher class में तुमको पता चलेगा, because speed of sound depends on the characteristics of the medium, such as elasticity and density. If the density of the medium is more, the speed will be less. If the elasticity is more, the speed will be higher. Now, which has more density? So, this is directly proportional to elasticity, and it is inversely proportional to density. But we are not studying this in this chapter. Only speed of sound in gas, which is air for us, because we encounter speed of sound in air for most practical purposes. So in air, the speed of sound increases with temperature, right? Yes.
So even some objects absorb some.
Yes.
Like cushion.
We'll come to it. That's a later part in this chapter. Right now, let's understand this topic. So second thing is, this is.
So how many more classes will this after this?
How come what?
How many more classes will this chapter take?
I think at most 1 or 2. Yeah. Elasticity of the medium, and this is density of the medium. So what does it mean? If the density is more, speed will be less. If the elasticity is more, speed will be more. Elasticity is flexible, like water. Yes, the water has, like, see.
But solid is denser, yet it is faster.
Very good. So I was waiting for this question. देखो, water will find its level. Plane हो जाएगा. At distance it is turbulent, so it is elastic. Elastic में क्या होता है? When the external force is removed, it will regain its shape. Okay? So like rubber band, you stretch it, so it is, when you leave it, again it will regain its original shape and size. That is called elasticity.
But if the speed is inversely proportional to density, then why would it be more in solids? The solids.
Because elasticity is many times more than the density. That's why. You will say now how solid is elastic? Rubber is elastic, everybody sees, it's obvious. But how come solid is elastic? That's what you might think.
Sir,
If it is because solid is elastic, that's why buildings use steel rods in the concrete structure. So bridges, they all use steel rod, not rubber. If it is rubber, then the bridge will go down and not come up. Okay, with the load. But on a steel, it just shakes like this, but still, once the load has passed, car, truck has passed, again it regains its shape. So the elasticity of steel is much more than rubber. You will understand about it in higher standards. So these two things are not in the syllabus, but I just gave it to you. Next is, because it is mentioned in the book and said it is not in the syllabus. So I just went little higher. Next is speed of sound.
sir, it is 1,500
Increases with temperature. In gaseous medium. Right? So what is speed of sound? So at 0 degrees Celsius, speed of sound is 344 meter per second. I think, is it true?
Sir,
Isn't it 343?
331. One second. Huh?
I thought it was 343.
331, that is at 20 degrees Celsius. At 22 degrees Celsius, we have 344 meter per second. So in different book, you will get it different.
Sir, it is
Okay.
1,500 meter per second.
And
That's right.
at 20, wait a minute, 26 degrees Celsius, it is 346 meter per second.
So not at 0.
So whenever 0 is a normal temperature and pressure condition, right? 0 degrees Celsius and 1 atm. 1 atm is the pressure at sea level. That is 1 atm, 1 atmospheric pressure. Okay. So what are you seeing? As the temperature is rising, the speed of sound in air is increasing. Correct? As the temperature is rising, the speed of sound is increasing. What happened to her? As the temperature is rising, the speed of sound is increasing from 331 to 344, 346, like that. Now your question. There is a table given in the book and it will also be in the volume. You can see different types of medium, solid, liquid and gas. And you can see the listed speed. Okay. So it is maximum in solid 6,420 meter per second in aluminum.
So when temperature increases, things will become less dense, right?
This is 25 degrees Celsius. Yes.
So if when temperature increases, things will become less dense, then how is the speed increases?
So elasticity also changes, no? It's the ratio of elasticity by density.
How does elasticity change by temperature?
Which is more flexible, a liquid or a solid?
Liquid.
So with temperature, it converts into near liquid. So elasticity will obviously increase with temperature.
Oh, yeah.
Flexibility increases, right?
So like
Or at least-
elasticity matters more than
Or density reduces. With temperature, what happens to density? Reduces. If density reduces, speed increases.
Sir,
It's a combination of things.
Oh, yeah.
It's a combination of things.
Sir, 1,500 meter per second is the average rate
For what?
for water speed.
What do you mean average?
Sir, I read it in my book, not in some other.
There is some hair in my mouth. I don't know what. It's sticking somewhere. Okay, it should go inside. Okay. So it is sea water, 1,531. So see, average means, let's say sound is traveling in this direction and there is wind blowing in this direction. Then the speed of sound is more, and if the wind is blowing in this direction, then the sound will reach slowly. That's why you take average to negate the effect of the wind. Okay? So everything, every velocity is average velocity only. Right? Everything that we calculate, total distance traveled upon total time is average velocity. Okay? That's how we learned what is average velocity. Because it may not be traveling with the same speed in different intervals. That's why average. Total distance upon total time. Okay? So it's just a name. Is it understood now? Next part is reflection of sound. So the question is, which medium the speed of sound travels maximum? Answer should be, which medium travels fastest? Solid. Okay? So that's the answer. That's the question here. Okay. Next is reflection of sound. So, sound, just like light wave, also suffers reflection. Okay? Light में reflection होता है. If light falls on a glass, it will be reflected. So, what are the laws of reflection?
Sir, I have a question.
So the incident ray,
Yes.
the angle of the incident ray should be equal
Also
to the angle of the reflection.
obeys laws of reflection, just like light waves. Yes, what is your question?
So like if whenever temperature increases, sound increases. So
Sound wave velocity increases.
yeah, I mean like sound's speed increases. So like if theoretically there's some place in the universe that's hot enough, could the speed of sound if theoretically there's some place in the universe where the temperature is high enough, could the speed of sound overtake the speed of light?
No. It's not like
Because speed of sound increases the temperature.
अरे जहाँ पे लाइट जा रही है, light travels by what factor?
So,
What is the speed of light? 8 meters per second. What is speed of sound? Roughly. So if you take it as 300, still you have a factor of 10 raised to 6. This is 1 million times more than the speed of sound. So 1 million थोड़ी ना हो जाएगा उससे. Light is the fastest traveling entity in the universe. Nothing can travel more faster than light.
So that is why whenever thunder occurs, we see the lightning first and then.
Yes.
so like if there's a place that's like 1 million degrees hot, then wouldn't sound travel faster than light?
It's a hypothetical question. In hypothesis, we talk in science. We talk about observed facts. We don't live in what do you call perception or hypothesis, assumptions. So not observed yet, I would say. The rest is speculation. In dream, you can think anything. Thinking में क्या जाता है? But whether in reality it will happen, that's a question mark. ठीक है? Okay. So sound wave also obeys laws of reflection, just like light waves. So meaning, suppose you have a board kept on some table. Let's say this is a tabletop. Okay, this is a tabletop. In your lab, and you have kept some sound producing clock. Let's say it is ticking like this. Okay. So on this table, let us say you have drawn a normal straight line you have drawn, and you have kept a pipe, hollow pipe through which the sound wave is traveling, let us say. So the sound produced will travel in this line.
Sir, it will be equal to the reflected.
Okay.
Angle.
Now the observer is listening at various positions. So he hears the, let's say he places his ear at different locations. Okay. So he hears the maximum sound when these two angles are equal. The angle of incident is equal to angle of reflection. That's when he hears the sound as maximum. So this proves that sound obeys laws of reflection. Got it? So whatever is the sound produced, same sound is heard here. Rest other places it is less. So only problem is, this is the sound reflector, some plywood or something. Size of the sound reflector should be comparable to the wavelength of sound. Should be comparable to the wavelength of sound, which is much larger. Okay, so it is comparable to wavelength of sound. You can find out wavelength of sound. It is nearly between 10 to 10 minus 2 to 10 raised to 2, like yes. Okay, 10 to the power minus 2 to 10 to the power 2. कैसे निकालोगे wavelength? Let us say here V is equal to f lambda, है ना? So sound frequency is between 20 Hz to 20 kilohertz. This is the audible range. So what is the wavelength? So lambda 1 is equal to V by f1. अगर तुम speed of sound को 330 ले लेते हो meter per second and 340 at room temperature. For simplicity of calculation, if you take speed of sound as 340, तो wavelength कितना आता है? 340 divided by 20 Hz. Okay, so how much it will be? 17, roughly equal to 17 meters. So for a low frequency sound, you need a large reflector. Okay, so for a high frequency sound, you will require a smaller reflector. Generally, the human speaking thing is between 600 to 1200 Hertz. Okay, in that, whatever we speak is in that range. So that will be reflected by smaller, but still, it is still much bigger than reflector of light. Light can be reflected by this watch also. Sound will not be reflected by such a small object. Because light का wavelength बहुत छोटा होता है, ठीक है? You learn it in higher classes. Sound wave का wavelength ज़्यादा होता है. So what is the wavelength I said? Roughly in between this. Okay. Is this here reflection of sound?
Sir, is it always that the normal, the reflected ray and the incident ray are the same?
Is it not in the same plane? The table plane? Yes, always. That's the second part of the law. So that's why I said laws of reflection, just like light waves, everything is obeyed. Okay, angle of incidence is equal to angle of reflection. Incident ray, the normal, and the reflected ray at the point of incidence lie in the same plane. What is the plane here? Plane of the table. This plane. So this is the plane in which they lie. All. You have the incident ray, the normal, and the reflected ray. All lie in the same plane. Okay. Next is we have to learn the applications of reflection of sound. Have you noted this down? Okay, fine. Here is it. So application of reflection of sound is echo, right? Applications of first is echo. Then you have reverberation. Okay, so we'll see what it means. Okay, so third is uses of multiple reflection of sound. We'll see all this. Okay, so let's first start with what is echo. Any idea what is echo?
Sir, the sound is
When I clap, I clapped it once, but when I hear one more clap.
Sir, the reflection of sound basically makes it echo.
Yes. When a distinct echo is, it is the reflected sound, the distinct reflected sound okay,
Sir, the
heard by the listener after the original sound ceases. Okay, so like if I clap like this, so the second I clapped here, right? Echo will be when without me clapping second time I hear the sound.
Sir, echo is more when there are no objects in there. Means less objects.
That is reverberation. That's second. We'll see what it is. Echo is just one more sound will be heard.
Yes.
So देखो, so one example of echo is like in hilly areas, right? When you shout out loud, then your voice only will be heard again.
Yes, sir.
Hello. ऐसे आएगा थोड़ी देर. Have you experienced it?
Sir, at the second sound is always lesser than the first.
Yes. Because some energy got absorbed. And energy is lost. If energy is not lost, then once spoken, the sound will exist in the universe. It doesn't happen like that. Okay? The sound, when I speak, when I stop speaking, there's no sound. You have to continuously speak to be heard all the time. And that's why you're losing energy all the time while speaking. So you become angry, then you eat, reload, speak again. Or play again, or do any activity again. Right? So since if a singer or a musician keeps playing, singing, there are breaks, right? At appropriate interval. That is basically to regain some energy and perform again. Okay. So can I erase that side, left side, or are you writing left side? Done? Some are not writing. Are you writing? Should I erase them? It is the distinct reflected sound heard by the listener after the original sound ceases. So, there go. So, there are conditions to produce distinct echo. क्या है? Let us say this is the reflector of sound. Reflector is called obstacle. जहाँ पे जाके sound will collide and come back. Or reflector of sound. Okay. Now somebody speaks. ठीक है, यहाँ पे सुनेगा भी तो यहाँ से इसका साउंड यहाँ जाएगा. लेट्स से वन वे इट इज बी, फिर यहाँ से वापस आएगा, तब तो सुनेगा ये इको. तो डी कितना हुआ? टोटल डिस्टेंस ट्रेवल्ड इज डी प्लस डी. डी गोइंग, डी कमिंग बैक, एंड लेट अस से टी इज इक्वल टू टाइम टेकन. तो एको प्रोड्यूस करने के लिए T should be greater than or equal to 0.1 second. ठीक है, क्योंकि when we speak, the sound remains in our ear for 0.1 second. तो अपने को जो reflected sound है वो 0.1 या उसके बाद में आना चाहिए, तो एको सुनाई देगा. इसलिए रूम में एको सुनाई नहीं दे रहे. ठीक है. दूसरा, डिस्टेंस कितना होना चाहिए एको के लिए? देखो, so if we take v is equal to
3 meters,
330 कितना था अपना 0 डिग्री पे? 334, right?
Yes sir. So 0 पे 331. नहीं 331.
331 था, so take 331.
So the distance is 3 meters.
अरे अभी निकालो ना. and t कितना होना चाहिए? 0.1 सेकंड. So therefore v कितना होना चाहिए? 2d by t होना चाहिए. Therefore d क्या हो जाएगा? v into t by 2. This is how distance of the obstacle can be calculated to produce distinct echo. v कितना है? 331. v कितना है? 0.1. 2. ये कितना हो गया? 2 1s are 2, 13. 2 6s are 12. तो अगर अपन 20 पे लेते हैं तो कितना आएगा? लिस्ट 344 लेके चलो फॉर द सिंप्लिसिटी ऑफ कैलकुलेशन. 344 ये ले लो. इवन नंबर है, 2 से कटोगे कितना आ जाएगा? 2 1 जा 2, 2 7 जा 14, 0.2 ऐसे आएगा. 0.1 मल्टीप्लाई करो तो 17.2. तो इको प्रोड्यूस होने के लिए जो ऑब्स्टेकल है उसका डिस्टेंस कम से कम 17.2 मीटर्स अवे होना चाहिए. कितना दूर होना चाहिए? 17.2. अभी आई एम स्टैंडिंग हियर. Is board 17.2 meters away? No. Front door. Everything is less than 70. So no reflection is reaching me after 0.1 second. So उसके पहले ही पहुंच रहा है. इसलिए I am not hearing multiple sound. Is it understood? अभी large auditorium होता, तब क्या होता? हाँ, कितने echo सुनाई देंगे? At least 6. Multiple echo, सब चीज reflect करेगी. ये करेगा क्या? इसमें तो मैं खड़ा हूँ, नहीं होगा. Ceiling से हो सकता है, 4 wall से हो सकता है. ठीक है? Which satisfies this condition. So what are the conditions to produce distinct echo? Distance of the obstacle should be equal to at least greater than or equal to 17.2 meter. And time of echo should be greater than or equal to 0.1. तब जाके echo सुनेगा. Anything less than this will not give you an echo. Okay. So I just told you what is echo of sound, right? And we have also learned about the conditions to produce distinct echo. So when we meet next, we will cover about बस next class में खत्म हो जाएगा. This and we'll have some questions. We'll be able to finish. So if we get a next class for 2 hours, it will be over. So don't miss. Next class is going to be the last lecture. Okay? Is there a possibility for you to miss the next class? When is it?
Next class is Wednesday.
Sir, if it is on Monday.
Next class is?
Wednesday.
No, sir, yeah, having a-
Today is also Wednesday, right?
This one, the next Wednesday.
Let me check. When is the
Next
next?
Wednesday is the next class.
Yes. I'm only wondering if it is a holiday.
No, the holiday is till Tuesday.
Okay. ठीक है. So your syllabus will be over. Anybody going on long vacation? Huh? No. Tuesday you are available, right? Tuesday नहीं. Next Wednesday. ठीक है.
Sir, sit at home and study.
On next Wednesday.
Sir, my exam is
When?
sir 19,000. Sir, not yours. It's not regarding this.
So if you have something, so next Wednesday is what date? Next Wednesday is 15.
Not sir, no sir, 19.
19 is very far away. Wednesday is 15. You can come.
But the syllabus
So I'll leave on to you. So any question about what we did today? Any questions about what we did today? No? All right.
19 is a Sunday.
We'll see you in the next lecture. Bye bye. Wish you all a very happy and safe Diwali.
Thank you.
Okay? Take care. Bye
What about it? बैग में चार्जर लेके तो आज ही लिया इतनी छोटी है प्रेरणा ले आ रही है मेरे बाल तो आ रहे हैं जाना अभी वो जाने नहीं दे नीचे अरे दिख जाता है उसको यार वहाँ पे तो लोग आए हैं